Let's look at another application of right triangle trigonometry. So we've got a setup here where we're given as much information as we need here. We've got 8,000 elevation to begin with at the bottom of the trail, and at the top of the trail our elevation is 11,100. So if I take the 11,100 and subtract the 8,000, you can see that this is 3,100 feet here. And we want to know the measure of angle B, the inclination. So we're going to take sine of B, and we know that's opposite over hypotenuse. So the opposite is 3,100. And then our hypotenuse is 14,100. Okay? And all I have to do then is take the inverse sine. So B would be equal to the inverse sine of 3,100 over 14,100. So let's enter that into the calculator. Okay, remember I need a second function, so I'm going to choose second, and then my sine to get an inverse sine. 3,100 divide 14,100. And our result is the inclination is 12.7 degrees. Okay, here's another application. We've got a situation here where we measure the building. We've got a 400-foot distance and an angle to the top of the building from the center point would measure 55.1 degrees. And then there's a statue at the top of the building of series, and that angle changes slightly to 56.5 degrees when we measure to the top of the statue. So from the bottom of the statue at 55.1 degrees to the top of the statue, 56.5 degrees, we're going to use trigonometry to determine what the height of our statue is. So let's just take a quick peek here. Let's look at these triangles one at a time. For right triangles. Okay, so for the first one, this is 55.1 degrees. And let's call the opposite side, which will be the height, B. And then we know that this distance here is 400 feet. Okay, now let's sketch the other one, slightly different. Okay, so this is a 56.5 degree angle. And we're going to relate this to the other one by calling that B prime, and this is still 400 feet here. Okay, so let's make note of the information we have and don't have. We don't have the hypotenuse, but we do have the adjacent. So we're probably going to want to use something like a tangent. So the tangent of 55.1 degrees is equal to B over 400. Opposite over adjacent. At the same time, the tangent of 56.5 degrees is equal to what we call B prime over 400. So we're going to calculate B and B prime, and then the distance between them, we'll calculate the height of the statue at the top of the building. Okay, so solving this for B, I'm just going to take the 400 over here and multiply. It's going to give us B, and then a slightly different result here. Will give us B prime. Okay, and then our answer is going to be B prime minus B. So let's go get those. Okay, so let's find B. B is 400 times the tangent of 55.1. Okay, so for B we're looking at, we'll round to two places, 573.39. B prime is 400 times the tangent of 56.5. Which gives us 604.33. Alright, so let's take 604.33 minus 573.39. 30.94. And let's attach the units to it. So our units have all been given in feet. That's the height of the statue.